I'll begin. All right, I think we're good to go. All right, so thanks for joining firstly. Really appreciate it. Today, I'm going to continue from last week. So last week, we started the hypothesis testing, and we did it for a two-tailed test. All right, so let me just share my whiteboard. Okay, so just ignore the problem for now. What I'm saying is ignore the text that you see there. So what we did last week, we did a two-tailed test where you would have, and stop writing. You would have your H naught, right? And you'd have the mean is equal to something, or whatever it is. And then you'd have H1. The mean is not equal to that same thing. Instead of the question mark, it makes it easier for you. Let's give it a value. Let's say 10, right? And then here, it's not equal to 10. All right, so you can ignore this part and ignore that. We had this hypothesis where H naught has the equal to, and H1 has the not equals to. And then when you have that, then your rejection region is a two-tailed test, right? So there's a rejection region here, and there's a rejection region here. Okay, so today, this evening, we are going to do a case where the rejection region is only on one side. So it can only be either here or it can be on the left side, but it won't be both. So I'm just going to check the chat. I'm not sure if I got a question. I am not. Yes. Thank you, JD. That is my fault. Okay. Thank you for that. That's silly me. Okay, so let me go back to my whiteboard. All right. Thank you very much for that. All right. So last week, what we did is we did a case where you'd have your H naught, you'd have your mean equal to something, and then you'd have your mean not equal to something. And when you have that, then it's a two-tailed test. In other words, you would have a rejection region on the left, and you would have a rejection region on the right. Today, we are going to do a case where the rejection region can either be on the right or on the left, but not both, like what you see here. All right, we're going to do a one-tailed test. And we're going to cover the case where we're working with a T distribution. And if you're not sure what that is, don't worry, I will explain that when I get to it. Okay, so let me clear the board, and then we'll tackle this problem that will show you pretty much what I'm talking about. All right, so let me just clear this out. Okay, just give me a second. Close the door. All right, let's begin. So let's look at this question. It says, Moyers recently launched a new flavored pudding, and the marketing manager now wants to assess whether this product whether this product is successful in the marketplace. If average sales per week are less than 5,500 rands. So let me just highlight that part or underline it.
Excuse me, sir.
Yes.
We can't see your whiteboard.
Still, what? Okay. Let me try again. Thanks for letting me know. Just tell me if you can see it now. Can you see the whiteboard now?
Yes.
Okay, thank you. All right. So let me get back to, I said actually earlier, because then you wouldn't have seen what I wrote in the whiteboard. So last week, we covered the case where H naught has your mean equal to something, let's say 10, and you'd have your alternate hypothesis, your mean not equal to 10. All right. And when you have a case like that, then you have two rejection regions, one on the left, yeah, and then you'd have a rejection region on the right as well. Okay, so that's what we did last week. But today, we are going to cover the case where there's only one rejection region. It can either be on the left or on the right, but not both. All right, so that's what we're going to cover now. So with this problem that I'm showing on the left with the text in the upper left corner, that's going to show us how to, that's going to illustrate the approach that I'm talking about. So we have Moyes, right? They make puddings and desserts, and the marketing manager for this company wants to assess whether this product is successful in the marketplace. And they're deciding that if the average sales is going to be less than 5,500 Rand, then that means it's not going to be feasible and they're going to withdraw this product. However, if the results would be more than that, or at least 5,500, then they would keep the product. Before we read on any further, okay, so what they're testing, all right, you're going to have your H0 and your H1 like before, except now, if you look at what I've underlined, it says less than 5,500 Rand. Less than 5,500 Rand would be this sign here. Less than 5,500, right? That'll be, and we'll be talking about average, because if you read this text, it says average sales. So we're still testing the mean. We're testing whether this mean is going to be less than 5,500. And then the opposite of less than, right, would be greater than or equals to. Okay, it wouldn't be this, because if it is this, then there's no case where we're including 5,500. Okay, so understand that this greater than equal to is the opposite of less than. All right, and that's going to be mu greater than equal to 5,500. Before I just continue, I'm going to check the chat for any questions. And also, okay, all good. All right. Now, you may want to ask, okay, how do I know where to place which one? Why not place less than here and place greater than equal to here? Okay. And the reason is that you need to just memorize it, okay? Your H1 will always take the strictly less than or greater than sign. It won't take less than equals to or greater than equal to. So H1 always takes these signs. Okay, it doesn't take the equals to. Just remember that. Okay, one more time, I'll repeat that. H1 always takes the strictly greater than and less than sign. Okay, so the inclusive symbol, as in the less than equal to and greater than equal to, will always go to H0. All right. Okay. Now that I've stated this hypothesis, okay, there's another thing you need to remember about this. This is a one-tailed test, okay? And how I know it's a one-tailed test is because the signs are not like last week where we had equals to and not equals to. This would mean it's a two-tailed test, okay, if that is the case. This is a two-tailed test. But when you have these symbols, the greater than, less than, then it's a one-tailed test, okay? Now, a one-tailed test can be further broken down into an upper or lower tail test. And how you know whether it's an upper or lower tail test, and this is how I remember it, okay? I always let the sign of H1 tell me where the rejection region is. I think of it as an arrow sign. Okay, so it's like an arrow. In other words, H1 symbol is this. So if I think of it as an arrowhead, it's pointing to the left. So that means the rejection region is on the left. That means if I draw my curve, the rejection region is here as the arrow is pointing. So it's telling me it's a lower tail test. So this is a lower tail test. Okay? Because the rejection region is on the lower side, not on this side. All right, so I'm going to pause there. Just make sure there's no questions. Does everyone understand that? Okay, you can memorize how to determine where the rejection region is, whether it's on the left or right in your own way, but this is the way I do it, right? It's always worked well for me. I use the sign of the H1 inequality to point to where the rejection region is. So because this is the less than sign, the arrowhead is pointing to the left. So that means the rejection region is here. So it's a lower tail test, okay? So when you're answering this question, you would need to tell the examiner what tail test is it, okay? Is it a lower or upper tail test? And this is how you do it, okay? All right, I'm just gonna check the chat. All good. Just unmute or drop a comment in the chat if there's any questions, okay? I'm going to assume everything's good. All right, thank you. All right, so let me clear this out. All right, so we have done step 1. We have stated our hypothesis. Okay, this is step 1. All right, now step 2 is to find the rejection region, just like we did last week. Step 2 is find the rejection region. Remember what I said earlier, that this is a one-tail test and the rejection region is going to be on the left. If I draw this curve, best I can, I'm going to shade this region here as our rejection region. All right, so I know it's a lower tail test and I know that the rejection region is on the left. All right. Now let's read a bit more about this question, okay? So it says the results from a sample of 18 supermarkets, okay? From a sample of 18 supermarkets. That means the sample size, which is represented by n, is only 18, all right? And remember, we are dealing with averages. If you look here, we're dealing with averages, right? So we're dealing with averages. Now, if you remember from last week's session, I told you that if your sample size n is greater than 30 and you are dealing with averages, right, then it is a Z statistic. Then it's a Z statistic. But if you look at what we have now, your n is under 30. It's only 18, and you are dealing with average. So when your n is less than 30, it is no longer a Z test. You are dealing with a T test. Okay, and this will make a difference because you're going to look at a different table than what we've been looking at before to find the rejection region, right? So this is a T test, right? And how we find the rejection region now is by looking at our T table. So let me just kind of open that textbook out and I'll show you what the T table looks like. So please find my textbook. Okay, so this is the table we were using all this time, the Z table. But the next page in the back, you'll see it says the T distribution. So now this is the table we're going to use for this test. Just going to check the chat. Okay, nothing. All right, so let's go back to this table. All right, this is the T distribution table. Now, I want you to pay attention to a main difference between this graph that you see here for the T distribution. Okay, so you look at this graph, you'll look at the area that's shaded. The area that's shaded is the far right area, whereas the previous table, the area that's shaded is the area between 0 and Z. So in other words, this table will only give you the area for the shaded region on the far right. Okay, so in other words, all the area inside here that you see inside this table that I'm highlighting, that is for when you're shifting your T value on the axis, and it's the area to the right. So let me just try and sketch it to put things in perspective, right? So if I draw this T curve, that, okay. Let's say this T value here, I'll make up a value. Let's say it's 1.1, right? Then the area on the right of 1.1 is given inside this table here. So you look at where sorry, let me take it back. This table works the other way. In other words, you will be given the area. You will be given the area. So say the area is 5%. Right? Say this area is 5%. What this table will tell you is you got to tell it what this area size is. So if you tell it it's 5%, it'll tell you what the value is on this axis. All right. So in other words, let's go to this table. Here's 5%. Okay. Your alpha, that's the alpha. If you look at the diagram, the alpha is pointing to the area, the size of the area. So if that area is 5%, then these are the values on the axis. I'll explain what the different rows are. It's very simple, but just assume that for an area of 5%, this is how you can find the value on the axis that corresponds to an area of 5%, right? Now, how you know which row to use is by using something called degrees of freedom. And the degrees of freedom is all it is, nothing complicated. The degrees of freedom, which we just denote as F, is simply just your sample size minus 1. So in other words, our sample size is 18. So your N is 18, so it's 18 minus 1, which is just 17. In other words, your degrees of freedom is 17. So you just tell it, you tell the table, I'm looking for an area of size 5% or degrees of freedom of 17. So if you go to your table, here's my area size, 5. And the degrees of freedom is 17, so it's just row here, 17. And that corresponds, right, to a value of 1.74. So the value on this axis here would be 1.74. 1.74. Does everyone understand that? That's how you use the table. And go to the chat. If anyone's confused, that's how you interpret the table. Everyone, give me a thumbs up if you want me to explain that again. Happy to do so. Otherwise, okay, I'm assuming everything's okay. All right, so let me just quiz you on this, okay? So let's go back to the whiteboard, okay? And let's say now, instead of 5%, okay, say the area size is 10%. Let's say instead of 5%, the area is 10%. Okay, let's say the area is 10%, all right? And your degrees of freedom is not going to change because your sample size is still 18, so your degrees of freedom is 17. In this case, what is this value here when the area is 10%? Looking at the table, and maybe I'll share it with you if you don't have your textbook open. So the area size is 10%, your degrees of freedom is 17. So if you go to this table, can you tell me what that value on the axis is? Looking at this table. Can you write it in the chat? Very good. Nicely done. Okay, everyone sees why it's 1.33, right? Because here's your area size, it's 0.1 or 10%. Your degrees of freedom is 17, so your value is 1.33. Very good, excellent. All right. Okay, I'm hoping everyone understands that, but please let me know if you don't. So this value is 1.33. So I'll write it there. 1.33. I'm just going to use 2 decimals, so 1.33 should be fine. All right. Now, just like the Z curve, right, which is symmetrical. In other words, at the point of 0, okay, if this area here, let's say this area here is 10%, and then this area is 10% as well on the left. If this value is 1.33, then this value must be minus 1.33 because it's symmetrical. Okay, both these distributions are symmetrical. The t distribution and the z distribution is symmetrical. So if you look at what we're working with, we're not interested in the area on the far right. We want the area on the far left. But that area is also 10% because if you read the question, it says at a 10% level of significance. So that's your alpha. That's your size of your rejection region. So in other words, if the area on the right is 10%, and that value on the t-axis is 1.33, then this value must be minus 1.33. Minus 1.33. So in other words, I'm just going to erase this part here. You found the critical region. In other words, everything on the left of 1.33 you will reject. Okay. Everything from there to there you will reject. And everything on the right you will accept H0. So now you found your critical regions, right? So you reject H0 if it's on the left of minus 1.33, and you accept H0 if anything is bigger than minus 1.33. All right, so that's your step 2. You've pretty much done step 2 now. Now we're going to move on to step 3. All right, I'm going to clear this. I'll check the chat in a second. Any questions? Okay, nothing. All right. So the next step is to calculate your test statistics. So step 3 is calculate the test statistic. Now, before we would calculate the Z statistic, Z test. But now we're not dealing with the Z distribution, we're dealing with the T distribution. All right, so the T distribution, you have your T statistic. Your T, you can call it T test, right? But as long as you say T, don't say Z. All right, make sure you say T because we are dealing with the T distribution here. Right, this is the T distribution, not the Z distribution. The value or the equation for this, it's in your formula sheet, so you don't need to memorize it, okay? Okay, it's T test equals X bar minus mu whole over S over square root N. It's very similar to what we did last week. Before, the only difference is instead of S, you had sigma, right? Last week. So it's just notation. It's not a big difference. S is the standard deviation of the sample, where sigma is the standard deviation of the population. But if you read the text for this question, there's only one standard deviation given, all right? And that is 788. So it tells you with a sample standard deviation of 788. So that is your S, all right? Your X bar is the sample mean. So that means you've taken a sample, all right, of supermarkets, that is 18 supermarkets, and out of those 18, you found that average to be 5,275. So that's your sample mean. That's your X bar. So your X bar is, I'll just write it here, your X bar is 5275. All right, so you have your X bar, you have your S is 788. Your N is the sample size, as we wrote it earlier. You only have 18 supermarkets that you sampled, so your N is 18. So I'm just going to remove this. N is 18. All right, so you got N x bar S. The only thing you need is mu. And mu is simply what is in your step one. What is mu? 5,500. All right, so that's your mu. So you have everything you need to plug into this formula. If you place all the values into this formula and enter it into your calculator, you'll get a value of, I'll write it down, T statistic is minus 1.211, minus 1.21. I'll just leave it at 2 decimal places. That's good enough. That's your T statistic. Okay, so before I move on, let me check the chat for any questions. Good. Okay. All right. Now, based on this value, okay, what you found in step 3, where does it fall here? Does it fall in the rejection region? Does it fall in the acceptance region? You got a value of minus 1.21. Your rejection region is minus 1.33. So does it fall in the rejection region or the acceptance region? Can you maybe just put it in the chat? What do you think? No one? You got a value of minus 1.21. And your rejection region is everything on the left of minus 1.33. I'm hoping everyone understands that minus 1.21 is on the right of minus 1.33. Okay, it's greater than minus 1.33. So we would accept H0. Very good, excellent, nicely done. So we accept H0. Okay, that's your step 4. Step 4, as you just state, you accept H0. Right. Now, if you look at the question, now I'll maybe just leave this to you to kind of make sense of this right now, and I'll answer it. We have accepted H0. Okay, we've accepted H0. Now look at what H0 is and what H1 is. Based on the text, based on the question here, do you withdraw the product or do you not? So in other words, do you keep the product or do you withdraw the product? Which option do you choose? Do you keep it or do you withdraw it? What decision do you make based on what you found in step 4? Do you keep it or withdraw it? Yes, very good. Okay, remember, the text says if the average sales is less than 5,500, so that means if here's your less than 500, it's this. So it means if this was true, if H1 was true, then you would withdraw the product. However, from step 4, you can see that you're accepting H0. So you're accepting this and you're ruling this one out. So it means the data shows that the sales is at least 5,500 or more. So that means this is not true. So that means you would keep the product, all right? Based on that. Okay, make sure you understand that. So how you would interpret this and how you would state this, you would always start with your level of significance. So at a 10% level of significance, okay, all right, we accept H0, right, and do not withdraw the product. This is how you would answer step 5. All right, and that is the question answered. Any questions? Everyone happy? Okay, it's seeming all good. All right, let's move on. Okay, so we've got one more hypothesis test to do, but now you're pretty much comfortable with this. The only difference now for this one is we're going to be working with proportions instead of averages. Right? But other than that, the same steps apply. Step 1, 2, 3, 4, and 5. All right. So let's go to an example looking at this problem here. Right, so it says churn is a term used to describe the rate at which a company loses customers to its competitors. And in the telecommunications industry, it's believed that the churn rate between cell phone service providers is not more than 15%. So this one's a bit of a tricky one because it says not more than 5%. All right. Okay. I'm going to give you some options and you tell me which one you think is the one that represents not more. So let me just get my pen here. Option 1, not more. Do you think it's this? Option 2, this. Option 3, that. Or option 4, that. Which one represents not more? Place your option in the chat. Not more than 15%. Okay, so if we say not more, which one are we talking about? Is it option 1, 2, 3, or 4? Okay, let me try and explain this again. The sign for more than, I think everyone agrees that is option 1, right? This is more than, right? This is more than, right? This is more than. Okay, so I think everyone's on board with this, right? So not more than is the opposite of the sign. And which one would be the opposite of this? That's pretty much what my question is. Which is the symbol that represents not more than? Does everyone understand why it would be this here? Option 4. This is the opposite of that. If there's anyone that doesn't understand that, just let me know. Okay, so the opposite of this is this. All right, that's the opposite of that. These are opposites. Okay. So in other words, if I had to state my hypothesis, my H0 and H1, let's make this eraser a bit larger. All right, so if I had my H0 and my H1, okay, this symbol would be here, and the opposite of that would be this. All right, and we're checking for 15%. If you look at what I underlined here, 15%. You can put 0.15 or 15%, it's the same thing. And now we're not testing means, we're testing proportions, which is pi, so not mu. Everyone understand what 4 is the opposite of that? But, okay. Okay, Sagnipo, okay, we'll explain. All right. More than, let's look at values, okay, to make it easier. If I say more than 4, then I'm talking about greater than 4, right? I think everyone's agreed on this. But this, when I say greater than 4, I mean it can't be 4. It has to be 5, it has to be 6, it has to be 7, okay? These would satisfy that. So the opposite of this would have to be 4, 3, 2, and 1. right? Let's just say it stopped at 1, but we can keep going to negative numbers, but to make it easier and to not clutter the whiteboard, 1, 2, 3, 4 would be the opposite of that. Okay, now 1, 2, 3, 4 means less than equals to 4. It has to have equals to because you can see there's a 4 included in here. So that's why this is the opposite of that. Does that make sense? All right, fantastic. All right, so now you've stated your hypothesis. Let's see if any of you remember how to determine whether it's an upper or lower tail test. Do you remember what I said about the arrowhead and using the arrowhead in H1 to tell you where the rejection region is? So is it an upper or is it a lower tail test? Okay, I mentioned earlier to use H1 and treat it as an arrowhead to point where the rejection region is. So is it an upper tail test? That means is the rejection region on the right or is it on the left? I'll draw the curve. So remember, upper is here and lower is here. Nicely done. Well done. That's right. It's upper tail test. Because, how do you remember that? Because I treat this as an arrowhead. Okay? If you learn it a different way, it doesn't matter, as long as you understand it. So that's an arrowhead pointing to the right. That means the rejection region is here. So it's an upper tail test, not a lower tail test. All right? So let's draw that. Right, that's the upper tail test. All right. So now you've done step 1, done. Okay. You've pretty much done step 2. We just need to determine the values here for the rejection region. Now with proportions, you don't have to worry about determining whether it's a t distribution or a z distribution. It's always going to be the normal distribution. In other words, it's going to be z always. It's always going to be z, right? Whenever you're doing proportions like we're doing now with pi, it's always going to be the z test. All right, so in other words, we are going to look at the z table to find these rejection regions. All right, so let's look at our level of significance, that area. Here's our level of significance, 10%. That means the size of this area, 10%. All right, so now we need to work out what is the value on the z-axis that corresponds to an area of 10%. Now remember, your z curve, it likes to make your life a bit difficult. It only gives you the z values for areas from 0 to that z value. So in other words, here's your 0, right? It'll give you this area. Yeah. All right. So if you're not sure what I'm talking about, let's look at the diagram. Here's your textbook. If you look at what I'm drawing, you can see I'm shading the same area that's in your textbook on the table. It's the area from 0 to a z value. So in other words, it doesn't care about this 10%. It'll only give you values for areas from 0 to that z value. So in other words, if the black area is 10%, what is the blue area? And remember I told you half the area is 50%. So that means the entire area from 0 to the right is 50%. So if this is 10%, then this area must be 40%. Okay, that's the remaining area. So we would go to our textbook, in our table, and we would look for where the area is 40% inside here. Okay. All right. So if you look here, the closest value you could get to 40%. is 1.28. Yeah, 1.28. 1.2. Yeah, there it is there. Okay, it's 0.3997. That's as close as you get to 40%. All right, 0.4. So your Z value is 1.28. In other words, that's the value here on this x-axis, on this horizontal axis, 1.2. Let's write it here. That's your critical value. That means everything on the right of this, we reject H0, and everything on the left, we accept H0. Let me just check the chat. Okay, no questions. All right. So now you've done step 2. All right. So we've done step 1. Here's step 2 done. Step 3 is to calculate the test statistic. All right. Test statistic. The formula for this now, because you're dealing with proportions, this you have to use this formula, which is in your formula sheet. It's P minus pi all over square root pi into 1 minus pi all over n. This is the formula. Okay. Now you have the values for pretty much everything. Okay. So if you read the text, your sample size, right, is 560. Okay, so your n is 560. Right. Your pi, the value for pi is what is in your step 1. What are you testing for? 15%. So for pi, you use 15%. Okay, but there's just one more symbol that you need to figure out, and that's P. What is P? P is your observed proportion. So that means if you took a sample, then what is the proportion of people in that sample that have churned? So in other words, if you read the text, it says 96 of them have churned out of those 560. So in other words, your P is the proportion, which is 96 out of 560, which is 0.17 or 17%. So now you have all the values to plug into this formula, right? If you into this equation, if you do that, you'll get a value of 1.33. That's just test statistic. And so now the easy part is compare this to your rejection region here. Where does it fall? Remember what we said? Anything bigger than 1.28, that means anything on the right of it, we reject H0. Anything on the left of it, we accept H0. So 1.33 is bigger than 1.28, so that means it falls in the rejection region. So in other words, we reject H0. This is step 4, right? We reject H0. I'm just going to clear the board. Let me just check the chat for any questions. No, okay. Okay, so we reject H0. And if we want to conclude, then what we're saying is that if we're rejecting H0, I'm just gonna, yeah, if we're rejecting H0, then we're saying this is not true. We're rejecting H0, and we believe this is true. So that means, okay, the evidence shows that the churn rate is above 15%. All right. So how you would state that? In words, you would say at a whatever your significance level is, at a 10% level of significance. All right. We reject H0. Right. Hence, there is evidence that the churn rate is greater than 15% or above 15%, however you want to write it, but it's the same thing. And this is your step 5, concluding it. Okay, does that make sense, everyone? Everyone happy? Any questions? Okay, that's what I wanted to cover today. This is pretty much your learning unit 8 done. Hypothesis testing. All right. If there aren't any questions now, please feel free to email me. But we have one more learning unit to cover. And then, yeah, then we're done. Okay, I hope this makes sense. I'll make the recording available by tomorrow. Yeah, even though it's a holiday, I'll post the recording up. But yeah, I hope this makes sense. I hope you understand the content. And yeah, you're pretty much almost done. So well done to making it this far into the course. I hope you're enjoying it. And yeah, you're almost done. Please go back to the board quick. Yeah, sure, Jimmy. Stay at it and then tell me what your question is. You just want to look at the board or you have a question? Oh, okay, sure. Sure. What I'll do is, I'll put it in the chat. Let me put it in the chat. All right, but if there's no other questions, guys, you can log off. Thanks for joining. I'll just copy it just so you can have it again. But yeah, feel free to ask any questions. And yeah, thanks for joining, everyone. You're welcome. Enjoy the evening.